Welcome to Digital Electronics EEE 301. In this lecture, we'll discuss about flip-flop and latches, sequential logic, latches and flip-flop. The course content are as follows: introduction, memory elements, then pulse trigger latch like SR latch, gated SR latch or gated D latch, S triggered flip-flop, SR flip-flop, D flip-flop, JK flip-flop, T flip-flop, and asynchronous input. Introduction. A sequential circuit consists of a feedback path and employs some memory elements. So this is the combinational circuit and memory elements. So you have the memory combination circuit here and also the memory elements. So if you look at here, this is our combinational circuit, memory elements. So if you combine these together, then we will get the sequential circuit. So it has the feedback path as well, like this. There are two types of sequential circuits. One is synchronous, another is asynchronous. Synchronous means output change only at specific time. Asynchronous means output changes at any time. So for asynchronous, the output could be changed at any time. And there are multivibrator, which is a class of sequential circuit. They can be bistable, which has two stable states, monostable, which has one stable state, and astable, no stable state. Bistable logic devices are latches and flip-flop. Latches and flip-flop differ in method used for changing their state. Memory elements. Memory element is a device which can remember value indefinitely or change value on command from its input. So this is a memory element, so it can change the value if you give any command. The characteristic table is like that. So you have given the command something like that: set, reset, or memorize or no change. So your QT is your current state. So if set that current state is don't care, it could be either 0 or 1, and your future state is 1. For reset, current state is don't care, and future state is reset means 0, set means 1, and memorize means your current state is 0, future state 0, or current state 1, future state 1. That means no change. Memory element with clock. Flip-flop are memory element that change state on clock signal. So whenever you are giving the clock, based on your command, it changes its state and stored in the flip-flop. Clock is usually a square wave, so clock could be positive edges or negative edges, and this is called positive pulses, the top one. So positive edges means if the clock changes its positive edge whenever going from low to high with positive edge, and negative edges means going down, like here, high to low. Memory elements. Two types of triggering or activation. One is pulse triggered and other is edge triggers. So pulse triggered is used in latches, where on means 1, off means 0, and edge trigger are used in flip-flops. So flip-flop could be positive edge trigger, which means on for 0 from 0 to 1, off for other time. For negative edge trigger, on means 1 to 0, off means other time. SR latches. The complementary output for SR latch are Q and Q prime. When our Q is high, then latch is set state. Q high means set state and Q low means latch is reset state. So for active high input SR latch, which is also known as NOR gate latch. So if we have R high and S low, then it is reset state. If S high and R low, this is set state. If both input low, then no change. Both input high, then Q and Q prime both low means invalid. So in latches we have the invalid state. And for active low input SR latch, which is also known as NAND gate latch, so where R prime low and S prime high is our reset state, S prime low and R prime high equals set state. If both input high, no change. Both input low, Q and Q prime high, both high, that means invalid state. The drawbacks of a SR latch are there is an invalid condition which must need to be avoided. So this is our SR latch, which is active high input NOR SR latch, and this is active low input NAND SR latch. So if you look at the table here, it works based on the characteristics table from here, which I already showed you in the previous slide. So if we start with S1 and R0, S1 means set high. Set high, that means our Q becomes 1, Q prime becomes 0. Just look at here, S1 R0. So Q1, Q prime 0. If you then put 0 0 in these two input, so 0 0, then it becomes 0 0, it remains same, no change. So previously it was 1 0, it will be 1 0. Then the next one, let me put where's the pointer, so 0 1. So for 0 1 it becomes 0 1. So 0 1 means reset. So then reset to 0, Q becomes 0, Q prime is inverted 1. Then 0 0 again, no change. So 0 1, 1 1, 1 1 is here, 0 0 invalid, 0 0 invalid. For this active low input NAND SR, so it could be represented as this one. This is the representation of NAND as well. So this is the inverted of this one, whatever we have here. So if you start with 1 0, so look at here, 1 0, it becomes 0 1. So 0 1. So 1 0 means set. So the output is 0 1, 0 1. 1 1, 1 1 here is no change. So it will be 0 1. Then 0 1. So 0 1 means 1 0. So 0 1 is 1 0. 0 means set. Then 1 1, no change. It will be 1 0. 0 0 0 0 here is invalid. So this is invalid. So we can look at the illustration here. Whenever we have S1 R0, so 1 0, just look at the first one, how it changes. So it will show with different color. So for, if you look at here, S1 R0, so S1 R0 output will be 1 0. So this is keep them 1 0. If you look at the next one, 0 1. So S0 R0. So S0 R0 output is 1 0. So 1 0, the red one. The third one is your S0 R1. So S0 R1, third one, it is 0 1. So 0 1. So similarly, fourth one, green one, if 0 0, then output becomes 0 1. And last one, 1 1 becomes 0 0. So now here we'll describe actually how we get the latches of different values. So as we already discussed, latches could be two types. One is NOR latch or NAND latch. So the basic function of latch is uh, the storage element which stores either 0 or 1. Just look at here. So this is your NOR gate. Therefore it's called NOR latch. So you have one input here which is R, another input here which is S, and your Q and Q prime is your output. Okay, so R means reset. That means reset Q to 0. Set Q to 1. Set means our Q will be 1. Reset means our Q will be 0. So this is the typical truth table for two input NOR gate. So for two input NOR gate, we know that if both of the input is 0, then output is high, otherwise output is low or 0. So if we consider that one, then just look at this circuit here. So case 1, say we put our S equals 0, R equals 1. So this is 0 and 1. If we put S equals 0, R equals 1, just look at the truth table here to input or get truth table. If your either of the input is 1, just look at here. If your either of the input is 1, then output is 0. You don't need to look at the second input. If either like these two, the boxes from this box, then it is 0. So we can say our Q is 0. If Q is 0, then it will come to here. So for this one, it becomes 0, 0. So if for NOR gate input is 0, 0, just look at 0, 0, the output is 1. So this Q prime becomes 1. So for case 1, we got for S equals 0, R equals 1, our Q becomes 0, Q prime becomes 1. So if your either of the input is 0, like either of the input is 1 or 0 actually, S1, so then your output becomes 0. So just look at here. If your either of the input is 1, say this one is 1 and this one we don't really know. So for this one we can say 1, otherwise either 1 or 0. So this output would be 0. So this Q prime will be 0. If this Q prime 0, it goes here. So for 0, 0. So 0, 0 output becomes 1. So then Q becomes 1. So now your Q becomes 1 and Q prime 0. Previously your Q 0, Q prime 1. So it changes. So it's not remains same. So if both 0, then previously you had Q equals 1, Q prime 0. So just consider like this 1 comes here, so 1, 0. So 1, 0, the output is 0. So this output is 0. Then this 0 goes here. So 0, 0. So 0, 0 output is 1. This output is 1. Then your Q becomes 1, Q prime becomes 0. So previously you had Q1, Q prime 0. This is again called memory or no change. So whenever S equals 0, R equals 0. Now look at the case 3. So for case 3, now change it. S equals 1, R equals 1, like S and 1 both 1. What will be your Q and Q prime? So if both 1, then output becomes 0. So if both 1, then output becomes 0. So if either of the input is 1, like this one 1, this could be 1 or 0. Similarly, this one, this could be 1 or 0. Then output 0. So for this one output 0, for this one output 0, 0, 0. So Q prime becomes 0, 0.